If you're listening, that's my cat. Each time, yeah, it is. Line up. There's probably a cat waiting, but you can do it. You can do it. Charlemagne, let her pass. It's okay. There. Oh. All right, so nothing really happening at the moment. But why don't I give you something to look at while I'm doing this? Because we are broadcasting. So 3 minutes to go. 3 minutes to go.
because it's become one of the most important tools.
Good. Very good. So should be starting any moment now. And, you know, I wonder if I can do this. I don't know if I can. I'm trying to figure out, is there a way to show a video inside Zoom? It should be.
Some of the issues that you might experience is while you stop sharing, participants cannot hear you. What happens is when you click this little share computer sound, Zoom is actually taking sound from your computer.
Oh, okay. So we're just going to share the. All right, good enough. All right. So what I'm going to do then, well, let's start the thingy first, and then we'll see if that works. All right. So hello and welcome. Oops, gotta get my audio recording running. All right, hello and welcome to the discussion for ethics, analytics, and the duty of care. Don't have anybody in the meeting yet with me. I'm just looking to the side because that's where that over there is where my Zoom meeting application is. But I thought I'd share a video and we'll see how that goes. I don't know if you can share a video on video. Wonder what the rights are under this one. It's probably like all rights reserved, but it doesn't say because YouTube. So, but hey, well, let's just try it out. Oh, here we have Sharita joining us. Hi, Sharita. And Sharita's gone. We're going to have one of those days, aren't we? And we have Sharita coming in again. So, hi again, Sharita. Still, I haven't seen Mark for a couple of days now. I don't know if it was something that was said in the course or if he's unable to join us or maybe he's just late today. I'm not sure.
There we are. Yay. Huh.
Yeah, we are. So I was thinking I would start off with doing something a little different and try to show a short video using this on how does AI work. Now, I suppose I should ask, I mean, is this likely to be new for you?
If it may not be completely new, but it may aid my understanding. How about that?
All right. Oh, and I have no idea what YouTube will do with the recording of this session with this video, but we'll figure it out.
Yeah.
Yeah. All right.
Well, you try it and then I will, and see how it works. And then I might try it this winter with my students.
Yeah, exactly. All right, let's give it a shot. So I'm going to share the screen. So there it is. So that's the YouTube video itself. Share sound, optimize for video clip, which I've just clicked on that. Share. So now we should be looking at blackness.
Yeah.
And here we go.
Artificial intelligence has become one of the most important tools in the modern world. It knows what tweets you want to read, it can understand your handwriting, and it can drive your car. AI are important because while humans are pretty smart and good at performing a number of tasks, computers are better. Much better. Or at least they can be if they're programmed by an above average intelligence human. The key to useful and powerful AI is the ability to learn and make its own decisions. And the burning question on my mind is, how do AI work? Computers, fundamentally, need to be told what to do, and a computer just doing what it's told to do is not exactly intelligent. So how can we get it to make its own informed decisions? This is the issue of machine learning. At the heart of this issue is a computer's ability to do two things. The first has already been mentioned, make its own decisions. Secondly, it needs to be able to make predictions, and a good AI will do so with minimal error. But how do we actually achieve machine learning? Well, AI are implemented in so many different ways. It's hard to answer this question very generally, but like most computer science problems, the solution starts with an algorithm. There are a lot of different machine learning algorithms and protocols that are applied in different circumstances, but to get the best idea of how this all works, I'm just going to focus on a popular and widely used method. A lot of AI systems are built up from what's called biologically inspired computing. After all, living organisms are some of the best thinking, decision-making machines around. If you want to build something that thinks, the first and most obvious point of call is to simulate some kind of brain, some kind of information processing machine that can make different decisions given different information. This is the basis of a neural network. Neural networks are a kind of rough simulation of a collection of neurons. In a neural network, the system takes in some starting information, which stimulates a bunch of neurons. Depending on which neurons are stimulated, other neurons get stimulated, and the whole process repeats until a final result is computed. So how do we actually implement something like this in practice? Well, simple neural networks are built up from systems called perceptrons. These are a kind of artificial neuron. Each perceptron takes in several binary inputs, x1, x2, x3, and so on. It uses these to produce an output, y, just by taking their sum. The output itself also has to be binary. So how do we deal with this? Well, we say that if the sum of the inputs is greater than or equal to some threshold, then y is equal to 1. If the sum of the inputs is less than the threshold, then y equals 0. The idea of a threshold is a good starting point, but in practice, we instead tend to say that the output is equal to 1 if the sum plus some negative number b, called the bias, is greater than or equal to 0. The bias is a representation of how easy it is for the perceptron to output a 1, but it's no different from the threshold idea. It just keeps everything centered around 0. This is a good start, but it's quite a basic model and doesn't allow for much complexity in terms of making different decisions. The problem is that each input, xi, has the same weighting. We can build up a better system if we assign a unique weighting w to each input. We can then multiply each input by its weighting when we take their sum. This allows for different inputs to contribute different amounts, and gives the perceptron a sense of importance for each input. Say we're building a perceptron that will compute for us whether or not we should go outside today. The decision might be decided by the following factors. Does the weather look nice right now? Does the forecast say it'll be nice all day? And do I have a jacket? These three factors might be of different importance to you. It might matter a lot that the weather is nice right now, so you give it a weighting of 2. It might matter a bit if the forecast says that it's going to be nice all day, so you give it a weighting of 1.5. And it may not really matter all that much to you if you have a jacket, so you just give it a weighting of 1. Now what you have to do is set your bias. Let's say you set it at minus 2.5. Remember, the bias has to be negative. And now you go and gather all of the relevant information. Say the weather does look good outside, but the forecast doesn't say it'll be nice all day, and you do have a jacket. The inputs are now known, so we can compute the sum, which comes out at 0.5. The output y is then equal to 1, as the sum plus the bias is greater than or equal to 0. So now that we can tweak each perceptron to act very differently, we can pile on layer after layer of artificial neuron. More layers means more decisions. More decisions means more outputs. This network of perceptrons is what we call a neural network. It starts with the output layer, where the initial data is processed, and then a series of hidden layers compute further information, until the final decisions are made at the output layer. So is that it? Does the whole discussion of neural networks end with perceptrons? Well, of course not. Perceptrons have a few big problems. Firstly, the output from a perceptron can immediately jump between 0 and 1. Making a small change to the weights or bias can lead to an entirely different result. Secondly, the weights must be predetermined. We might not always choose the most suitable values. So we'd like a way for the system to be able to adjust the weights itself in order to minimize error when making predictions. To deal with the first problem, we need to change the actual structure of the artificial neuron itself. Instead of using a perceptron network, we instead use what's called a sigmoid neuron. Sigmoid neurons give an output determined by the sigmoid function. The argument of the sigmoid function, z, is just the sum minus the bias. If z is very large, the sigmoid function is practically 1, but if it's very small, then the sigmoid function gives out practically 0. Now we have a function where making a small change to z will only make a small, gradual change in the output. As well as fixing our original problem, the sigmoid neuron has a continuous spectrum of outputs, unlike the step function before. So now we can build up a network of artificial neurons that can make a bunch of different decisions based on what starting information it gets. But how can it actually teach itself to adjust certain parameters, like the weights? Well, it just so happens there's an algorithm for that. The backpropagation algorithm is a method used to train neural networks. To utilize backpropagation, the neural network has to be given some training examples. This is just a set of inputs for which we know the desired output. A bit like data you would use to fit a curve in statistics, it uses the given outputs to compute its own outputs, predictions. We then need a way to compare these predictions to the desired outputs, a kind of measurement of how good our neural network is. For this, we define the cost function. The cost function takes the sum of the difference squared between the desired output and the prediction. If all the predictions are close to the desired outputs, then the cost function is roughly 0. But if the predictions are off by a lot, then the cost function will give back a very large value. The obvious goal here is to get the network to minimize the total cost. This is done by adjusting the weights so that they're optimal for minimizing the cost function. But to adjust the weights, we need to calculate something called the gradient of the cost function. And this is where backpropagation comes in. I'm not going to go into the detail on the maths behind backpropagation. That requires its own video, and one that I'll inevitably be making in the future. But backpropagation works by using two phases: propagation and weight update. To start the propagation phase, we give an initial guess as to what the weight should be, and then enter the training inputs into the system. The inputs are propagated through the network as usual, until the network produces outputs. After the network makes its predictions, an error is calculated for each desired output. The reason for doing this is that the errors for a neuron in any particular layer, say L, can be expressed in terms of the errors of the neurons in the next layer up, L+1. So starting from the output layer, the errors are propagated backwards until an error has been calculated for each neuron in the network. Once all of the errors have been calculated, they can be used to calculate the gradient of the cost function. As I mentioned previously, this is used to slightly optimize the weights, usually in an algorithm called gradient descent. The weights are only updated a small amount each time, the rate at which is called the learning rate, unsurprisingly. Having a small learning rate means that the training examples could have to be run many hundreds of times before the weights are optimal, which might not be very practical. And a learning rate that's too large may cause you to overshoot the optimal values. But in practice, we now have a way to train a neural network, however complex, to give the best possible outcomes it can. The only downside is that it needs to see some examples first. Training examples are a very common technique in machine learning. Take for example Microsoft's Tay tweets, a Twitter AI that learns what to say by reading other people's tweets from across the internet. The idea was well intentioned and started out innocently, but like a lot of things on the internet, it went quite wrong. Tay was eventually deactivated after people started having some not so family friendly conversations with her on Twitter, and Tay picked up some bad habits. But neural networks are an incredibly useful starting point for thinking about AI, and the wider field of biologically inspired computing in general. This leads the way for concepts like genetic algorithms, which a computer can use to teach itself how to solve a variety of problems. At this point, I couldn't say that I completely explained how AI works. That would be pretty much impossible, let alone in one video. But hopefully I provided some decent insight into how to get a string of ones and zeros to think just like you. Maybe even better. If you've enjoyed this video and you'd like to see more, be sure to subscribe to the channel. And if you're interested in computer science, check out some of my other related videos.
Okay. So, hi, Jim. Welcome.
Hi there. Thanks.
So you came in partway through my experiment with videos, although that seemed to work pretty well. I don't know what YouTube will do to this.
The sound was a little bit difficult. I had to pump the sound up really high on my computer.
I found
So,
the same.
yeah,
Yeah, I did too.
Yeah. So, but now you know how AI works, right?
yes.
And my head is
Sure.
spinning.
Yeah, you sort of almost, want to go back and listen to that video on half speed, bumped up with the sound, and take copious notes as you go along. But Yeah, it's interesting. To me, it's interesting, obviously, but it's interesting because it makes it clear, I think, that there's a lot of tweaking that happens with AI. It's not a one program fits all kind of thing, and it was clearly just a first rough approximation of AI, but we could see some of the things that need to be tweaked, like the activation functions for the neurons, and then the size of the learning that takes place in back propagation. And of course, they didn't even get into any discussion about, well, just a minor discussion near the end about Tay, the biased racist AI. But they didn't really talk about the nature of the data that's used to train the AI, and how we decide what counts as an error and all of that. Any reactions?
Yeah, that whole thing about deciding what counts as an error that you just mentioned, I mean, that's what struck me is the AI is really highly shaped by human intervention. I mean, the results, the outputs. Yeah, just how much human involvement there is in the training. There's an awful lot of room there to even subconsciously introduce the programmer's bias.
Yeah. Not just bias, but also error, oversight. There's a range of things that can go wrong.
I mean, even deciding what counts as an accurate output is a very subjective thing in many cases.
Another thing too that this video made clear, when we looked at the input, there's Mark. Running a little behind today, but he's here, and that's good to see. I was afraid that we had lost him forever, and I always worried.
Some difficulty finding the Zoom session. I had to go.
Yeah.
Yeah, the activity center link, it doesn't work.
Yeah.
Yeah, I had to go to module 8 to find a December 3rd
That's
link.
what I finally did.
Wow.
The module 7 link told me that no, this is scheduled for November 26th. Anyhow, we got here.
Yeah. Okay. And this is probably everyone who was going to join. So I'm glad you all made it. Jim, you missed our wonderful video, but happily it's a video, so you'll be able to watch it after this session. Or not Jim, Mark. I experimented with embedding video. Sorry about that. We, of course, delayed for, jaunty plaid. We delayed for 1 week that module. And as a result, I had to rejigger all my schedules and make that work with Zoom. And obviously I failed in some respects. I thought I was just plugging it in. Oh well.
So you were not just sharing a video screen there, you had it embedded somewhere?
No, what I did is I hit share screen at the bottom, and then there's a couple little check boxes on the lower left. One is to share the screen audio so that you could hear it, albeit badly. And the other one was to optimize it for video sharing. And I would expect that what it does at that point is just grab the video directly from source. At least if I was designing Zoom, that's how I would do it. But I'm not sure whether it took it off my desktop or took it off the source. But anyhow, it was optimized for video. So it was actually very easy to do. And
every time in Teams, when we have somebody who wants to share the screen, share a video, we have to tell them, you have to stop sharing. You have to find that share computer sound. And
Oh,
Teams
Yeah.
and Zoom do the same thing, but they call it different things and they hide the tools in different corners of the screen.
Yeah. And I find the interface to Teams isn't as intuitive as the interface to Zoom. Like
Yeah.
for Zoom, all there was share audio and optimize for video. That's it. You know, it's really hard to miss. But you do have to see it there, though.
Yeah.
But and the tricky part is selecting what I want to share, because I've got so many screens and things going on here on my desktop that I can share any of a dozen different things. So I have to get the right one. So anyhow, getting back to what I was talking about, the one spot on the video where it talked about, you know, is the weather prediction for a warm day? Is it going to be warm all day? Do I own a jacket? That's all the results of a whole process of labeling and classification. They had to pick out those three things to assign 1 and 0 values to as input. But, you know, I mean, how do you determine what things, you know, how you're going to classify things as your input? Why didn't they ask, for example, do I have a rain jacket?
Right.
Well, I guess we could argue it'd be pretty irrelevant, but maybe not. You know, and, you know, is it going to be nice out? Well, that's pretty imprecise. Why didn't they use an actual temperature value?
Yeah.
Will it be 60 degrees? So this isn't really bias at all. I mean, like choosing to use temperature, well, maybe it is if you choose to use it in Fahrenheit instead of Celsius, because people like Mark could understand it fine, but the rest of us who live in a Celsius world, not so much. But, you know, choosing to use precise temperatures rather than valuations of nice, not nice, you know, these don't really seem like bias to me, but they certainly are decisions that need to be made.
Don't we all know somebody that when it gets to, let's see, 22 degrees, 65 degrees, start saying it's freezing and start reaching for a down jacket? I mean, we all know those. Yeah. See?
Yes.
Where
Yeah.
I'm the opposite, and people are always, I mean, I'm from California. I own a bunch of short sleeve cotton shirts. That's basically all I own. And if
Yeah.
it gets down to 50 degrees, people are like, aren't you freezing? I'm like, well, no, I don't think anybody's ever died. 50 degrees weather, you know, it's a little chilly, but I do have foul weather gear. I do have a t-shirt someplace that I could put on under this short sleeve cotton shirt. So don't worry, I'm fine. So I don't know that AI is ever going to catch up to diversity of human experience.
Go
One
ahead.
question I have is the decisions in terms of choosing the training. So that would be another major decision, would it?
Yeah. I like to use as an example, because it brings it right home to us, the example of automated essay grading. Because it's a nice example of one of these machine learning examples with multiple outputs, right? And
Yeah.
we saw one at the end of the video. So you feed it in the essay and out pops a grade at the other end, 1, 2, 3, 4, or 5, let's say, or A, B, C, D, or E. And so the training, because we need, you know, this might need to be a many layered neural net, but and the training would consist not just of one data point, but, you know, the entire text of the essay. But let's say we set that up, and people have set that up. So the training set is going to consist of a whole pile of essays and the grades they actually received.
Right.
So immediately there's a whole bunch of questions that arise, even before we think about whether this is actually going to work. Where are we getting our essays from? Particularly, do they all need to be essays that answer the same specific question? Or could we allow some variation in the question? Do they all have to be on the same topic, in the same subject?
Do they have to be in the same language?
Do they have to be in the same language? Let's assume they do, because I can't imagine the system working unless they were all in the same language. So, and this is what happens in one of these workflows too, right? First, you'll run the essay through the auto translator, then you'll run the essay through the grader, but now you're grading both the person who wrote the essay and the auto translator.
Yeah.
Yeah, no, you've lost the person that wrote the essay at that point.
Yeah.
I would say.
Yeah. Especially given, the output of the audio transcriptions that we've seen here. But, maybe if we become really, confident in transcription or translation, we might be okay. It might get really good. But who's doing the grading of these for the training set? If we ask just one teacher to do it, or one grader to do it, that seems like a bad plan. So maybe we should get a range of graders. Should all the graders be teachers of that subject, or is it okay to use teaching assistants the way we do in the real world?
Mm-hmm.
Do they have to be grading according to a rubric? Presumably that would be the most fair, but at least I know when I was grading essays at university and college, I had a rough idea of what I was looking for, but I certainly wasn't grading according to a rubric. And I don't think most people grade essays by rubrics. I don't know, you've all taught, or at least been taught. What's your experience? Are the professors using, or teachers using, grading rubrics for you?
They're
Or
telling us that we need to do it.
Yeah.
And they're telling us that the students need to have it before
Mhm.
doing the assignment.
Right.
So then you have to try to work out, well, okay, how concrete am I going to be? And it's you could say that critical thinking might be that in the essay, you have to have 3 different perspectives of something that might be critical, but it's very hard.
Because that just produces essays by numbers, right? So it's similar to paint by numbers, but
Exactly. So it's extremely hard.
Mm.
But
Are you going to have a different AI for each identity group, each age bracket, right? I mean, I see this as a insoluble, well, at least a wicked problem, if not insoluble.
Well, it's a hard problem, for sure.
Yeah.
Jim?
We had rubrics for grading placement. Placement
Mhm.
essays. And they were, on organization and then mechanics like spelling and grammar. And there was a section for voice. Now that left it a lot up to the grader to determine whether this person was, but it was just to wasn't graded. It was, are you ready to study at this level or not?
That's
I liked
interesting.
that it included more than just the mechanics, but I don't know how you would train an AI to detect whether this person is exercising their voice. Like,
Yeah.
I'm just trying to think of what decisions did I make with regard to that. Anyhow,
So, yeah.
I in my master's program, we were often given rubrics for assignments. It wasn't on the essay. It was more structural. It was useful if you wanted to work toward the expectations of the instructor. I think I succeeded in also being interested in what I could learn.
Yeah,
Right.
But
yeah,
That's
exactly.
always the problem, or
Yeah.
Yeah.
a problem. In my looking at academic writing, so I'm probably the oldest person here. I know it doesn't look like it, but
No. No.
Or at least we're all of a similar age. Let's put it that way. So
yeah,
as a
let's
returning
put it that
student,
way.
and looking at writing, that my big takeaway from the last couple of years that I've been a distance student at a university is what is expected is first drafts
Hmm.
of fairly young people. And that's the level of writing that's expected. And as I point out to professors, not only is that what's expected, that's all that can be assessed. There is no assessment past that level. And so when you say, how are we going to train the AI? Are we going to use Shakespeare? Are we going to use the current novelists? I mean, certainly we're not just going to use 19-year-old upper middle class white students. I mean, I think we've settled that, I hope, across medical research and everything else. But for the AI, and so I struggle with this because I prefer to try to write at a higher level, and yet I find that I am graded by the rubric. Did I have the sufficient number of words? Did I include the significant terms? And then if I connect that to any personal experience, that's commented on. Oh, thanks for throwing that in.
Yeah.
And
That's it.
where I taught and, will teach a course, we value personal experience. And if somebody asks me, how many words should this, project be, I will tell them, I can't tell you how many words, write it. So
But that won't fit into a rubric.
Well, I have to come up with them. So quite honestly, the rubrics that I come up with are quite broad. And I
And I
think
can
I'm
imagine
doing
you'll
it
get
because
pushback
somebody
on that.
tells me I need to do it. Yeah.
All right. Well, let me throw a slightly different example at you. And so let's see if the same considerations apply. My new AI is going to be, let's say it's a test proctoring system. If you don't like the ethics of that, we could pick something else, but I want to keep it relevant, right? And so it's going to do facial recognition of the person sitting in front of the camera taking the test. So it would see basically what all of us see. So we could train that as well, right? We could train it on a large set of faces, and so that when we feed it a new face, it'll be able to come up with the correct identification based on, I guess, some previously existing example of our faces. So it would have previous examples of each of the four of us. But of course, in any situation, we're going to look a little bit different. We might be wearing jaunty plaid on exam day, for example.
That would
And
probably
we
be
need,
bad.
and we need the AI not to freak out. I do like the hat, by the way. I think that's a
Thanks.
great.
I wore it in honor of, the Scottish philosophers. They're certainly having a big impact on me.
So now, but basically the process is going to be the same, right? We're going to train it on a whole bunch of photographic data. It'll come out with its prediction of who it is. And then using back propagation, we can correct it. Or, we'll just have, we'll feed in the image, and then the trainers will say, well, that's so-and-so, that's so-and-so, that's so-and-so. And they'll do that, 30,000 times or whatever. It does take a lot of work to train these systems sometimes. Now, we talk in grading the essays about rubrics. Would it make sense to use a rubric for facial recognition?
I don't know how that would work. How would it not be?
That would be
personal?
a rules-based system. That would be a rules-based system rather than machine learning.
It seems like it, doesn't it? But then why isn't a rubric a rules-based system for essay marking?
Well, I think it is.
It is.
Unless, and Sharita, maybe this is something you can do. Go ahead and make your rubric to satisfy the admins and keep on grading the way you always have.
Well, yeah, yes and no. Because somebody will follow the rubric and say, I have put in all the stuff that you want.
Yeah.
Why
I have
not
a
give
minimum
me an
number
A
of words,
plus?
and I included the 6 terms. Give me an
Yeah.
A.
Give me an A, yeah.
Well, if you have
Sorry, go ahead, Jim.
Oh, Jim
a
froze.
rubric, then you can train an AI to write that essay for you, which may be a lot more wording, yes, but or you can tweak the rules of your algorithm to match whatever, Sharita's rubric, Mark's rubric, Stephen's rubric. And
This reminds me of, let's see, what's the term? When we keep escalating our weapon systems.
Arms race.
Arms race, exactly. So we'll have AI races. And I guarantee who's going to win that one. It's going to be the students every time.
well, I mean, it's
time.
happening. There is an arms race. The more proctoring and the more controls that are put into learning management, if you can manage learning at all, the more controls that are put into structures, the more people find ways to circumvent them.
Yeah, then it just becomes a game rather than a creative act.
Yeah,
and I'm confused about facial recognition. Why, when we have iris scanning capabilities, are we even concerned with facial recognition? I mean, you just need, but that demands a high quality camera. But all I got to do is go like this, and either I'm me or I'm not, if the camera's good enough. So all this concern with facial recognition to me just seems a waste of time and money that could be spent on teaching salaries and things.
Well, similarly with other biometrics, right? Like my phone uses facial recognition, which is really annoying. I'm always having to go like that to it. And it doesn't like it when I'm wearing a mask. But my previous phone, which I liked a lot better, I just used my fingerprints and it would unlock. And I love that because I always have to tap the phone anyways to activate the facial recognition. So why can't I just tap it and it recognizes who I am? But these systems are easy to fool. And in any case, a system like Proctorio, for example, isn't just doing facial recognition. In fact, they deny that they're doing it at all. But it's doing things like, am I looking to the side? Am I looking down at a source? Did I consult my phone, right? Am I paying attention to the test? A set of things like that to determine whether or not I'm cheating. So now there's a whole range of things, not just who I am, but what I'm doing that this AI is assessing. And, in a certain respect, it almost doesn't matter who I am. I've already logged in, right? So I've proven who I am as much as the system's ever going to be able to tell. So, but again, rubrics for that, it's like when I think of AI, I always find it hard to think in terms of rubrics. The classic example I use it in other circumstances, but it totally applies right here. Suppose I'm an AI or a human waiting for my mother to come in from the train station. So there's a crowd of people coming in. And I look at all the people and say, there's my mother. And I ask myself, how do I know that that's my mother? Well, let's check, right? She's 5'4". She has gray hair. She has that green jacket I gave her. So I've never given my mother a green jacket, but pretend. But so.
But what if she just came back from the spa and she has a whole new outfit on and changed her hair color and let's say got a facelift? No problem. You'll know
I'm
her.
still going to recognize her.
Absolutely. Without a thought.
Yeah. But what if grading like that? I mean, this speaks to what you were talking about, Mark, where you go over and above what the rubric said. I do that too. I did that all throughout my academic career. I mean, that's, to me, was the secret to getting an A, right? Figure out what the professor wants from the test, do that, and then do more. Of course, you're not allowed to do, you're not allowed to make that the rubric, but that's how I did it. It's pretty simple.
And I have a different approach. I figure out what I want to do. Yeah. And then I try to make sure that it includes what's in the rubric. And as I point out to some, the friendlier teachers, you have no way of grading that. Yeah. There's no way to acknowledge that.
It was a bit hit and miss, though. That was the problem. I used to do that in the earlier years of my academic.
You got trained, educated. Oh yeah, educated. That's it. Good.
So, does it make sense to use rubrics then? Or maybe we're just making a big mistake using rubrics all along.
If you're having an AI grade essays, and you're using essays to train the AI to do that, isn't the AI in effect creating its own rubric?
Arguably, yes, it is. But
is that rubric available to learners? Is it available even to teachers? Like you talked about the opacity of machine learning.
Yeah.
And what about this problem of marginalization or amplifying the margins that we have with social media? Would the AI then fall into that and actually narrow what it's looking for rather than expanding what it's looking for?
Because it is going to kind of zero in on the one perfect essay, isn't it? We think.
You train it, the more rigid I think it would become as a non-computer programmer person.
I don't know if that's empirically true, but it could be. I honestly don't know, right?
And we didn't know what social media would do, but here we are.
Yeah, but there might be an answer to that question, and I just don't know it. Or there might not be an answer. We hit the limits of my knowledge there for sure. But it's interesting. So when we train these AIs, and we do the whole thing, and that results in a set of weights, as discussed in the video, between the different neurons, and as well the different activation values for the individual neurons, depending on how we've, depending on what kind of AI that we're using. This is what we call the model. And so arguably the model is the rubric or the rubrics. Don't know how to describe that. But of course, this model is not expressed in terms of words or principles. Is it fair to use that as a mechanism for evaluation?
Awfully opaque.
It's awfully opaque, but it's what we actually do in the train station when we're recognizing our grandmother or our mother. It used to be grandmother in my example, but then I got old. So, and I
My
keep
kids.
Yeah, but I don't have kids, and
Yeah,
I won't
maybe
allow
that doesn't work out.
Nephews.
yeah, I do have nephews. So maybe here's the real question. Is there anything fundamentally different about grading a paper or recognizing a person in a train station?
Well, I would say yes.
I think there are fewer points of comparison recognizing someone in a train station than there are in recognizing what I would consider quality voice, critical thinking in an essay.
Well, but that might not matter depending on the grading scale you use, right?
Yeah.
If you just use A, B, C, D, or E, or sorry, A, B, C, D, or F, for some reason we don't use E. That's just 5 points. And you know as well as I do, if you've taught, you give a paper a quick read, without any analysis, whether it's an A paper or an F paper. I mean, in the first paragraph.
Yeah.
Yeah, you don't even need to finish the paper. You know where this is going. And yeah, you could apply your rubrics after the fact, and that's probably what you do.
Let me read you a sentence from a rubric that I found that is a rubric for participation. One of the hardest things to play with, right? So listen to this sentence. If this person were not a member of the class, the quality of discussion and knowledge building would be diminished markedly. What do you think of that?
Quantify markedly.
Yeah.
Well, yeah, but I mean, does that?
So you can't invite Stephen Hawking to present to your class, obviously.
No.
That would lower the quality of your class markedly.
And knowledge building is, introducing that as a concept for evaluation of a person. Some people are knowledge builders, but other people are not. And that doesn't mean they're participating less or more.
Exactly.
To my view.
Exactly. But that I took that from, various examples of rubrics with participation.
Yeah. And it's a good point for sure. And now I've argued in the past, and I've argued this with respect to competencies, but I think it applies to rubrics as well. With competencies, you take an overall profession or skill domain, and you break it down into a set of individual skills. And the criticism I've made is that you've taken a difficult problem of recognizing whether a person is competent and transformed it into 10 different difficult problems of recognizing whether a person is competent. And I think that's true. Ultimately, when we look at our rubrics appear to be classifying in an objective and neutral way the demonstration of the skill or capacity that a person is supposed to show in the work. But that skill or capacity nonetheless needs to be in some way recognized by the evaluator. And you can't, in an essay or something, you can't just go in and measure it. It's going to be in these vague terms that are, as they say, subjectively evaluated. I prefer to use the word recognize because, not everybody reading the paper is going to be able to see, they've done this, they've done this. But presumably an educated professor could. What do you think about that? You're all supposed to say, you know what, Stephen, you're right.
No.
It just brings up to me, and I mentioned this before, that most professors are subject matter experts and very slightly trained, if at all, in teaching. Whatever that is. And it also, this suggests to me also, as you were talking, I realized, of course, now we're simply talking about text.
Yeah.
But there are other forms of communication. And here's another thing I struggle with in my classes. I have to negotiate each time I want to use a different media.
Yeah.
Mm-hmm.
And then that brings up the obvious subject that the person I'm negotiating with has no idea what I'm talking about.
Yeah.
Basically, I mean, to a varying degree, but at a very low level. I've never spoken to a teacher and said, oh yeah, I love whatever videos. And, that's one of my interests, and I'm, can grade it technically and visually and blah, blah, blah. No. No. Their only concern so far that I've got is the length of the video, how long.
I think I'm going to retire
Minimum
again.
number of words. What was that, Sharita?
I said, I think I'm going to retire again.
Well, I'm thinking about what Stephen said about recognizing competence. So our community college is moving in the transition to become a polytechnic university. It's going to be very employment oriented. And our main employment here in the Northwest Territories is mineral extraction. So trades, big thing. There, it's not too difficult to recognize competencies. Can you put the burner back together correctly? Can you diagnose, I don't know what, airflow volumes for a burner? Can you fix a cat engine? And essay writing isn't a big part of that.
Yeah.
But we also have sort of more values-based, and I've heard a lot about values and ethics and things recently. I don't know where I was watching all those videos. But we want people to be I don't think they use the word well-rounded, but we want people to be positioned to succeed and I'm going to paraphrase and say, be happy and satisfied.
Yeah.
I have no idea how we begin to measure competency or how we recognize. Yeah, I guess we can recognize if someone appears to be happy, but can you put a rubric to it? Could an AI?
I know.
Well,
I
I'm
would
just
be.
thinking about what decisions you would have to make to train an AI on what is a fulfilled person.
Hmm.
Well, you could ask the people in Bhutan who have the measurement of gross domestic happiness as their measure of fulfilled citizenship, and I guess they would have rubrics. So, but yeah,
Social score in China.
see, that's the, yeah, exactly. Those two are two sides of the same coin.
And I don't know if that's the kind of society we want. Now in Canada, we have 30 million people. You know, in our courses in our college, we have, you know, maximum enrollments of 30 students. I've never had at the Learning Center here, never had more than a dozen. Online, I think we had 20. So we don't have to scale. I always say if we had 1 billion people, we'd have to rethink what democracy means. We'd have to rethink, you know, what control
problem.
means.
Arizona
And
State
it is-
University has 100,000 online students. Michael Crow, and Michael Crow, the whatever his title is, president, chancellor of ASU, and he's working to double that. And I have some questions about the quality of education there. Not enough to sign up and go through the program. But I wanted to bring up something before we're running out of time here. So we're trying to figure out how to apply AI to the current educational system. But
Mhm.
here we are in a connectedness MOOC, and we're not discussing how AI could be used to create learning networks and peer-to-peer learning and assessment of learning across peer networks, which
Yeah.
to me is a more possible use of AI to support a network of learners rather than this hierarchical problem that we're struggling with.
Well, that's a good point. And also it speaks to something I've seen and thought about even earlier today on the ethics of AI literature. A lot of it's focused on avoiding doing wrong things, as opposed to using it to build up something new. And even if that something new isn't perfect, it's something that we didn't have before. Especially like things like building a community, you know, bringing together the right people with the right interests that have technology that works with the other people's technology. So you don't bridge together Apple and Mac people, or Mac and Windows people, I should say. And yeah, the matches might not be perfect, but they would be better than what we have. And this is especially the case when we're talking about a university with, or even a course with 100,000 people in it. How are you forming groups? It doesn't have to be perfect. Pretty good would probably do the job. And it's interesting because the same questions still apply. How do you train an AI to do that? Right? Well, you're going to probably, give it examples of previously formed groups that worked and previously formed groups that didn't, or that might be hard. So what you might have to do actually, and this is a thing in the field, you might have to generate a training set automatically. So basically we write some software that generates a whole bunch of possible groups, mixing and matching different characteristics, and then describing the results of that generation, and then using that to train our AI, which, solves some of the problem, but again, it's an order of magnitude, again, more difficult. But, you can do this, though.
Well,
Or
and then,
even-
there's some big decisions that have to be made. Do you want homogeneity or heterogeneity?
Yeah.
Right? I mean, right from the gate, it would be a huge
Mhm.
What decisions that we make.
Yeah, exactly. And I always remember I had some great aunts that taught in one-room schoolrooms. And I met some of their students, and they were well-educated people,
Mhm.
even though they grew up on a ranch, in my case, at that time in the New Mexico territories.
Yeah.
Excuse me. So, yeah, I mean, I just think that what we're doing here in this course is, this is an emerging model that I think is going to change things. And I don't know if you all follow Brian Alexander, but one university a week closes in North
Yes.
America. And that's for the past 5 years. Nobody talks about it, but that's 250 institutions at least, and I'm sure there's more. And at the same time, the University of Southern New Hampshire and Arizona State University have probably absorbed as many students as those other institutions lost, since they're all tiny little institutions. And these two institutions, I mean, you can throw in MIT and whoever you want. So there's something really going on. And to me, again, back to the arms race thing, as common folks, speaking for myself, I'm never going to get into MIT, and I have no interest in Southern New Hampshire University, although I'm sure they're perfectly nice people. But I am more interested in finding people that have similar interests and are kind of a similar age to study with. And that I'm not finding that.
When you were talking first about using AI for groups, Mark, what came to my mind was Facebook's friend recommendation. Now, I know that is geared toward maximizing profit and clicks. There's decisions made about that. But, this recommendation thing has been highly refined both by Facebook and Google. And is that something that we could piggyback on? I hate to use the word tweaking the algorithm, making different decisions about what's important that would help people connect. And then, Stephen, when you were talking about, randomly assigning groups, I was wondering about a training set where you start with self-selected groups. Now, knowing human nature, that would tend to homogeneity. But it might be another starting point in, what is attractive, and then can the AI transpose those outside of the narrow field that we select on?
Yeah, I
look at our skin tones here in this small group,
and age range. Yeah, it's all
this
very
is
narrow.
And
self-selection. And
yet
age
it's
range too.
open to the whole world.
That's the conundrum. Yeah.
Really feels unfair.
And
Yeah,
that
I
has
have
do
to
with
say-
resources. If you had $1 million, Stephen, just to promote this course,
yeah.
and and the time, so to take half $1,000,000 and take a couple of years off, if you had the time and the money to promote this properly, you would expand the group. Now, I don't know how much time you want to spend in Africa and Asia, but it could be expanded.
Oh yeah.
But that's resources.
Yeah.
And obviously
I mean,
we all have
budget.
our own resources that we bring it.
Yeah. It wouldn't even take $1 million, like $10,000 worth of, Facebook and Twitter ad. I'd have thousands and thousands of people in here. And then if it was a decent course, it would take off from there.
So what you need is a grant writing partner.
Yeah. Yeah, and the desire to market a course.
And
Of course,
then
then
to test out the 1,000 and then the 10,000 and the 100,000 version, because each one will present its own challenges.
yeah. Although the way I do courses, I mean, it scales up pretty well. This part of the course where we have these discussions, that's the part that doesn't really scale. But that doesn't stop me from having discussions with groups of people that, the other 100,000 people can tag along with, I could set it up so that, I do a timer and take the first 10 people in and say, okay, you guys are my discussion group this time. But it also helps kind of having the same regulars week after week after week, because we get to build on themes and things like that. And, your input actually shapes the direction of the course. And I find that valuable too. So it's a mix, but that's going to be unavoidable no matter what, I think.
So that the model of clusters, there's the cluster model of networking,
Yeah.
can that, and again, these are ideas that have not been tried as far as I can tell, but that might be some way to try to, and then if you have the principle of inclusion, diversity, equity, and access, which is I always add access, and it makes a nice idea so I can remember the term. If that is one of your guiding principles, then the AI would be pointed in the direction of heterogeneity, at least at times, just to balance the natural human tendency to homogeneity, if nothing else.
It would be interesting, again, assume a course of 100,000 people. It would be interesting to have an AI organize people into these groups. And of course, it would have to have a mechanism for selecting people who would actually participate in the groups, because a lot of people wouldn't. But, I've read on numerous occasions, and I think not without validity, that you can't just put people in a room and expect magic to happen. You're going to have some kind of organization or moderation or something, like even in our discussions, right? You've probably seen, right? I'll prompt the discussion from time to time as we go through it. But, we could have an AI that looks at, say, the way I do discussions, and there's plenty of examples that it could use now. I've been doing it for a while now. And then is added to these automatically generated discussions and seeds or prompts the discussion. And if it was a good enough AI, it might be like an artificial Stephen. You really couldn't, no group could tell whether they're getting the real Stephen or not.
Or Joe Watson instead.
Yeah, Joe Watson instead. Yeah. I mean, there was the case, and I think we mentioned it or ran across it earlier in the course, where a professor used an artificial tutor on his students without telling them, and they never detected that it was an artificial tutor. Not ethically questionable, of course, but if we said, at any meeting that you participate in this course, you have an 89.5% of receiving an artificial Stephen instead of a real Stephen. But, it's a good AI Stephen, and you can test it to see how you like it. That could work, couldn't it? Of course, how would you evaluate whether it was a good Stephen or not?
Yeah. See, again, I would go back to, while you were talking, I'm thinking, okay, so a good AI in the connectivist model could make sure that, so I'm a big fan of Kathy Davidson. I've heard her say lurking is learning. So you do have to allow for that, but this course allows for that, right?
Oh, yeah, totally.
Anonymity and even to you, the designer of the course.
And there are lurkers. So hi, lurkers.
Oh yeah, absolutely. Yeah, I see that.
You know you're there.
Yeah, that's good. On the other hand, I can imagine an AI that would say, okay, I got 100,000 students, back to Kathy Davidson, each one teach one. And I can guarantee that you're going to get a different person every time you're broken into dyads. No matter how many times you do it, you're going to get a different person each time. And so there's heterogeneity built into the AI. And then I can see small group participation. And so you could have the same 6 or 10 people as a cohort or something, and then they could be part of a larger North American cohort or English speaking cohort, right? And to me, that would be a better use of AI rather than trying to figure out, if I'm really mean, if I'm trying to game the system. I mean, I guess you have to have those if you have assessment, but the focus to me would be on the connections, the connectivity.
To me, those are categorization issues. Like deciding whether someone is from North America, or deciding whether someone is mean, or deciding whether someone is preferably a lurker, or, all of these are ways of classifying individual potential participants. And they're the sorts of things that we can do after the fact. But, if we're using an AI, we'd almost have to do it. And I've seen this done. I've seen systems where this is applied. In fact, in our LPSS system we built a few years ago, we tried something like this, where first you run all of your people through a classifier of some sort and organize them into categories. And if you're using deep learning, you don't even need to name the categories. The label is just for humans, right? But what the AI would do is just organize them, and you set the parameters, right? How many different categories would you like? Pick a number. What kind of categorization system would you like? I mean, there are different ways. If you took just on a 2-dimensional plane and put a bunch of dots at random, right? And then somebody asks you, okay, now organize those dots into 4 categories. You could organize them by dots that are closest to each other. You could organize them by, naturally viewable clusters, or there's any number of functions you can use to organize those dots into 4 categories. So you need to pick one of those. So organize all of your people into categories, and then based on that categorization, have another algorithm that takes people of certain groups of categories or whatever and organizes them into groups. So it's a 2-step process. And that could work. And like I say, I have seen a recommendation system actually work on that basis. And you might ask, well, why would we do it that way? It would actually be faster. Because instead of trying to compare everybody to everybody, you're comparing categories to categories. And so when you're forming groups, it doesn't matter which particular individuals you're just picking people from those categories, and you're picking well-known organizations of categories, or organizations of categories that are well known to work as groups.
And then you could change as the leader of the, whatever it is, learning environment. Then you could, do these faceted, you could organize into different facets. So that you could push a button, each person would have a unique partner for one exercise, push a different classification button, break into groups, and on and on and on. And then that would be a very useful function.
Yeah.
As the leader of the course, the person with experience doing this, whoever that is, that would be very useful for the 100,000 who would just, otherwise.
Can you imagine a course with 100,000 people it would basically run 24 hours a day, 7 days a week, right? And just be a constant process of categorization, reforming groups. And you just drop into the course, hang in there for as long as you want, and then leave.
Yeah, I
That
do
would be-
imagine that. I keep looking. I keep looking. And obviously now you've gone beyond what any one subject matter expert can even monitor, much less lead or control. And that's why I keep reaching for this network, because you would have subject matter experts, and you would have technology experts, and
Yeah.
you would have other kinds of expertise, and that's what I would like the AI to sort out, rather than imposing requirements for assessment.
But again, you're picking categories of people and saying, I prefer these categories, right? And we're back to the categorization problem. But on that note, because it is after 1, we should wrap this up so that I can have some lunch because I'm getting hungry. Next week is the last week. I'm running behind, so sadly behind on my videos. So those will continue after the end of the course if you want to follow them up. And I might do a wrap up at the end once I've done all of the videos. But I'm just locked into this video process, and it's doing so much good for me that I want to keep doing it, even if it's doing less good for you. So the next week in the course is the last week, and ostensibly it's about ethical practices, and basically, and it's a continuation basically of the conversation we've just had, because we've sort of moved from this idea of how does an AI work and what are the steps into how would we use this in practice and how would we make this work in practice. So we'll pick up that discussion. Again, there'll be the session on Monday and the session on Friday. I don't have them booked into Zoom yet, so those links don't exist yet, but I will make a concerted effort to get all of the links right. So I'll book them into Zoom so that they all start up properly and be indexed properly so that you can actually access the sessions, or anyone else who isn't familiar with the vagaries of how I do sessions. Sounds good?
Yes.
So they will be in section 8, or they'll be in the activity center. Which is the first place that you usually pay attention to correct them?
I pay attention to the activity center. That's where I focus most, although as was observed today, that's the part that broke. But that's probably because that's what I paid attention to. So your first port of call is the activity center, and if that doesn't work, then go to the module, and if that doesn't work, send me email. Although, as you've probably seen, when I'm online here in a video, I'm not
Yeah,
really
he didn't answer my email or my chat. So
Of
on Zoom,
course.
but whatever. That's
Yeah.
why every course meeting needs at least 2 people. I've been saying
Yeah,
that.
it really is better to have one
Absolutely.
person on air stuff and another person doing the tech.
Yeah.
Yep.
Yeah.
Absolutely.
I will till the end of my days. I will promote that, but it probably won't happen because of the resource issue. So.
Yeah. So resourcing and control issues. I have control issues. Sure, everything's done according to the way I want it to be done because I'm trying out things here. But anyhow, all right.
Good.
Next week, last week,
Bye,
we'll
everybody.
lurch on.
Hope I can make it. Bye.
Thanks for being by, everyone.